Welcome back to the Curiosity Beast. This is part 2 of our journey into dark energy and the fate of the universe. If you missed part 1, go watch it now. We explored why scientists predicted the Big Freeze as our ultimate fate. Today, we're revealing what changed, why dark energy might be weakening, and what that means for whether the universe ends in ice or fire. Let's dive in. When we left off, the 2024 Dark Energy Survey hinted that dark energy might not be constant. So astronomers turned to DESI, the Dark Energy Spectroscopic Instrument in Arizona. DESI's mission? Map 40 million galaxies across 11 billion years of cosmic history. Over 900 researchers from 70 institutions, all working to understand dark energy. In 2025, the first results arrived, and they're extraordinary. DESI built the largest 3D map of the universe ever created, using nearly 15 million galaxies. Every dot is an entire galaxy with hundreds of billions of stars. Using this map, astronomers measured baryon acoustic oscillations, BAOs. These are fossilized sound waves from the early universe. By tracking how they change across time, researchers can measure exactly how fast the universe was expanding at any moment. They combined DESI data with cosmic microwave background radiation, supernova measurements, and gravitational lensing, and the signal became clear. Dark energy's influence is changing, and not just changing, decreasing. The data suggests dark energy weakened by roughly 10% over the last 4.5 billion years. Think of a car accelerating. The gas pedal is still pressed, but the foot is lifting slightly. The car still speeds up, but not as fast as before. The universe is still expanding, still accelerating, but the rate is slowing. Drop a comment. Did you know dark energy might be weakening? Let me know what you think this means. But how confident are we? In science, confidence is measured in sigma. 2 sigma is 95% confidence. 3 sigma is 99.7%. 5 sigma is the gold standard at 99.9994%. DESI alone gives us just above 2 sigma. But combined with other measurements, it reaches past 3 sigma. Some combinations hit 4.2 sigma. That's 99.99% confidence. Strong evidence. But not quite 5 sigma yet. We're close, though. And that's exciting. So what does weakening dark energy mean? 3 scenarios become possible. Scenario 1. Dark energy weakens but stays positive. The universe still expands forever. The Big Freeze still happens. It just takes longer. Scenario 2. Dark energy weakens to 0. Expansion continues at a steady rate. No acceleration. No deceleration. A coasting universe. Still ends in the Big Freeze, but slower. Scenario 3. Dark energy continues weakening until it goes negative. And this is where things get wild. If dark energy becomes negative, it flips. Instead of pushing galaxies apart, it pulls them together. Expansion slows, stops, then reverses. Galaxies start moving toward each other, faster and faster. The universe begins to contract, and we enter a completely different endgame, the Big Crunch. If you're still watching, hit that subscribe button. Because the Big Crunch is nothing like the Big Freeze. Imagine the Big Bang in reverse. Everything collapses inward. Galaxies collide and merge. Stars are torn apart. Space itself shrinks. As the universe contracts, it heats up. Temperatures rise. The cosmic microwave background that's currently 3 degrees above absolute zero starts warming. 10 degrees. 100. 1,000. Eventually, atoms are ripped apart. Matter breaks down into plasma, then into fundamental particles. And finally, everything crushes back into a single point. A singularity. Just like the one the universe began with. Except this is the end, not the beginning. Total annihilation. The opposite of the Big Freeze. Which is worse? Freezing to death over trillions of years? Or being crushed out of existence? The Big Freeze is slow, peaceful, lonely. Nothing ever happens again. The Big Crunch is violent, catastrophic, final. Everything destroyed. No trace left. But there's another possibility. If the universe undergoes a big crunch, what happens to that singularity? Does it explode again in another Big Bang? This leads to a cyclic universe, expanding, contracting, exploding, over and over, forever, each cycle lasting hundreds of billions of years. We'd be living in just one cycle among infinite cycles, an eternal cosmic heartbeat. It's poetic. But is it true? We don't know yet. Now, before anyone panics, even if dark energy is weakening, we're talking incomprehensible timescales. If it takes billions of years to weaken by 10%, it would take hundreds of billions more to reverse entirely. The sun dies in 5 billion years. Earth will be uninhabitable long before that. This is not a threat to anyone alive today or for billions of years. But what this discovery does is profound. It tells us the universe is more dynamic than we thought. The fundamental forces shaping reality evolve. And if dark energy isn't constant, maybe other constants aren't either. Maybe the laws of physics evolve over time. Maybe the universe is stranger than we imagined. DESI is entering its 4th year of a 5-year survey. By the end, 50 million galaxies measured, and other missions are joining. Euclid Roman Space Telescope, Vera Rubin Observatory. These will provide the data needed to reach 5 sigma confidence. And then we'll know. Big freeze or big crunch? Comment your thoughts. Which ending seems more likely? And which would you prefer? The Curiosity Beast explores the deepest mysteries of existence. If you love this content, subscribe and join our community of curious minds. Because right now, scientists are measuring the fate of everything, and in the next few years, we'll have the answer. Thanks for watching. Stay curious. And remember, the universe is far stranger than we ever imagined.